Good morning, students. Today's question from January 23rd and 2025 question, and this question is belongs to electrochemistry. So now coming to the question, E naught Cu plus 2 becomes Cu, that is E naught value 0.34 volts, and Zn plus 2 becomes Zn, that is the minus 0.76 volts, and Az plus becomes Az, that is the E naught value, that is the 0.80 volts, and Mg plus 2 becomes Mg minus 2.37 volts they given. So here they given the standard reduction potential values they given. So how to calculate, that is the reduction potential values or oxidation potential values. Here see, Cu plus 2 becomes a Cu, means here oxidation state is 0. So plus 2 to 0 means oxidation state is decreased. Oxidation state is decreased means this is the reduction only. So that's why they given the reduction potential value 0.34, and this is also Zn plus 2 becomes Zn, so 2 to 0, then this is also reduction potential value, and here plus 1 to 0, this is also reduction potential value, and 2 to 0, this is also reduction potential. So they given the standard reduction potential values for different ions they given. So now what they're asking, which reaction having, so here they given some options. In these reactions, which have most negative delta G naught value they're asking. Most negative delta G naught value they're asking. So delta G naught value we have to calculate. So delta G naught, what is the formula? Delta G naught equal to minus NF E naught cell, minus NF E naught cell. So this is the formula. So now N means that is the number of electrons involved in the reaction, we can calculate, and Faraday, that is the Faraday's constant, and this is the E naught cell. E naught cell, for the each and every reaction we have to calculate the E naught cell, but only they given the each ion reduction potential value only they given. So first total cell potential we have to calculate. So cell potential value how to calculate? E naught cell equal to cathode reduction potential minus anode reduction potential value. This is the formula of E naught cell. Cathode reduction potential minus anode reduction potential. So now calculate the E naught cell for first equation, that is the E naught cell for A. E naught cell equal to cathode reduction potential. Actually this is equal cell representation. First anodic cell, and this is the cathodic cell. So cathode, which is acting as a cathode, Az plus becomes Az. So Az plus becomes Az, that is the given, these are all are reduction potential values only. If the given oxidation potential value, we have to convert it into the reduction potential value, but the given reduction potential values only, so directly we can take. So now what is the cathode? Az plus becomes Az, that is the cathodic half cell. So that reduction potential value, they given the 0.80 volts minus anode reduction potential, here anode which is zinc, so zinc reduction potential how much they given? Minus 0.76 volts they given. So now 0.8 minus of minus plus, so 0.76, so totally this is the 6, 8, 7, 15, 1.56 volts. This is the E naught cell for first equation. So now delta G naught value calculate for first equation. Delta G naught equal to minus N means that is the number of electrons involved. Here zinc is becomes Zn plus 2, here 2 electrons involved. Here Az plus becomes Az, here only 1 electron, but when you are doing the balancing equation we will get 2 electrons only. So N value is 2, and Faraday, that is the 96,500 coulombs. And next one, E naught cell. E naught cell for the first equation how much we got? 1.56 volts. So this is minus 2 into 1.56, do it. 2 6s are 12, 2 5s are 10 plus 1 11, and 2 1s are 3.12 volts. So this is the delta G naught for first equation. This is, now calculate the delta G naught for second equation. First E naught cell of second equation calculate. Cathode, which is a cathode here? Magnesium. So magnesium value, reduction potential value how much they given? Minus 2.37 volts minus Anode is a which one? Zinc. That is the minus 0.76 volts, minus 0.76. So now do it. Minus 2.37, minus of minus plus, that is the 0.76. So total value 13, 1 and 11, 1, 3.13 volts minus 3 point, that is the E naught value for the second equation. Now delta G naught value calculate. Delta G naught equal to minus N. N means what is that? Number of electrons involved. So in the second equation, how many electrons are involved? Two electrons only. So 2 into Faraday into E naught cell, that is the minus 3.13 volts. So minus of minus plus. So Faraday keep it like that. So 2 into 3.13, 2 3s are 6, 2 and 6.626 Faradays. So this is delta G naught value for the second equation. Next, this is the B equation, and next one C equation. First of all, calculate the E naught cell for the third equation. E naught cell, what is the formula? That is the cathode reduction potential minus anode reduction potential. So for that third equation, cathode which one? Magnesium. Magnesium value is the minus 2.37 minus anodic value, that is the Az. Az value how much the given? 0.8. So this is minus, so both minus only, so add it. So 7, 3, 8, 11 and 3.17 volts. This is the E naught cell for third equation. So delta G naught calculate. Delta G naught for the third equation, third cell. Here how many electrons involved? Ag becomes Ag plus 1 electron only. Here Mg plus 2 becomes Mg, 2 electrons involved. So when we are doing the balancing equation, here in this cell 2 electrons only involved. So N value is 2 minus delta G naught equal to, what is the formula? Minus NF E naught cell. So minus N value is 2 and Faraday and E naught cell, that is the minus 3.17. So minus of minus plus. So this is 2 7s are 14 and 2 1s are 2 plus 1 3 and 2 3s are 6. So this is the 6.34 volts for the third equation. Now do it for fourth equation. First E naught cell calculate for the fourth equation. E naught cell. What is the cathode? Here Az is a cathode, copper is a anode. So Az value how much? That is the 0.80 minus cathode reduction potential minus anode reduction potential. Here copper is act as a anode, so then that is the 0.34 volts. So then 0.80 minus 0.334, then 6 4, so 0.46 volts, that is the E naught cell. Now calculate the delta G naught value. Delta G naught equal to minus N value. Here how many electrons are involved? Here also 2 electrons only involved. So 2 into Faraday into 0.46. So totally minus 2 6 are 12 and 2 8 are 2 4 are 8 plus 1 9. So 0.92 Faraday volts, that is totally. So this is delta G naught values for A equation how much? This is minus 3.12 and for the B equation plus 6.26 and for the third equation that is the 6.34 plus value only, and this is the fourth equation minus 0.92 Faraday. So now in this Faraday, that is common for in all the four cells also. So now which is what they are asking, which reaction having most negative delta G naught value? Here most negative, this is minus these two, second equation and second one and third one we are getting the positive values, and first one we got the negative and fourth one also we got the negative, but here this is minus 0.92 Faraday and this is the minus 3.12. So which is more negative? First one is only more negative. So which reaction have most negative delta G naught value means that is the first reaction only having most negative delta G naught value. Thank you.